In this video, I would like to quickly recap what we've seen so far and give you perspective about where to go from there. This is the end of our introduction to Cables series. And of course, I hope you learned a lot, but it was just a very small glimpse about all the different possibilities that Cables offers us. So I would like to tease you a bit, and so you can learn more areas that you could be of interest, and hopefully recap everything we did so far. So my goal for today would be to make just animated cubes, and I would like also to create a small bonus video where we can also generate some audio content, so to go alongside our cubes. So how could we do this? Now we are very familiar with the basics, right? So we know we're gonna have to put the main loop, and you will notice that the UI changed a bit. There's the new background and color of the ops because Cables was updated recently. So okay, we have a main loop. This is very, very easy to do. We know we're gonna probably use some orbit controls. Okay, so far so good. So far what we've seen, if we wanted to create cubes, was to use the mesh sensor. And it's the perfectly good and valid op. Now I want to go a bit further and hint at what would come next, maybe in other tutorials, would be to use the texture workflow. So this is more intermediate. It's basically, instead of using the points that we generate and make a copy from the CPU to the GPU, we create once a texture that stays on the GPU, and then we modify the position of our cubes in the GPU directly. So far, we've been, if we remember correctly, let's just make you the standard workflow. Let's say I want to make an array of cubes. I can use this points cube op that would just generate random positions. Okay, and gives me an array of points x, y, z. Okay, now if I was if I were using the other workflow, the standard one, I would just create a mesh instancer. I know I need a cube because this is the base shape I want to instantiate. I'm gonna remove, I don't need to draw this mesh. I'm connecting the cube, I'm connecting the geometry, and I'm connecting now the position, right? And because it's too big, of course, either I multiply so the cubes are very spread apart, or I can just simply reduce the size of each instance, and I have here cubes. I'm saving. So far so good. Now what I was saying is that if I want to modify the position of these cubes here, let's say that I'm here and now I want to I don't know, put the sine wave on the cubes. Well, you know that this is an array 3, right? So I will need to split it with array unpack, modify the coordinates, and pack it again so that it goes on the mesh instancer. So let's do this very quickly. Array unpack 3. Okay, I'm pasting this. Now I get 3 arrays. I'm gonna create a timer. I'm gonna put a sine wave. This we've seen so far, so I'm going a bit quickly. And then I'm gonna do array multiply to multiply one of the coordinates, let's say the y coordinate, by this sine wave, but I'm gonna move the amplitude to 3. So you see that I'm doing a bigger sine wave, and I'm connecting this here. I'm multiplying the y coordinate. So this, I put a vis array, you see it's changing in real time. And now I need to repack. So array pack 3, and basically get my x, y, and z. Use this array again and disconnect the previous one. Right, so now I've created this kind of a small animation of my cubes. So this is perfectly fine, as I said before, but you notice that the timer here is basically updating all the coordinates, and this is CPU based. And now in the mesh instancer, these positions are continuously changing and uploaded to the GPU. So it's fine for most cases, but if you have a heavy workflow and you really need to maximize the performance, the best way would be to basically, as I said before, convert everything to a texture and update the texture because it's already on the GPU, and draw directly from there instead of copying everything back from the CPU to the GPU. So the basis for this would be to use this op called array to texture. So let's try and see how it works. So how does it work? Well, first we know that we need to connect to a main trigger. So as usual, I would suggest we do a sequence. Okay. Now, because this is on my left, I'm gonna just change here. We need to connect this here, and we need to take our data. So basically, what it does, it's very interesting as an op, and you see that there are many different options here, right? So the goal here is to create an image based on data. But don't think of this as an image. Think of this as just putting data in a way that the GPU is happy with. We are using WebGL. We are very limited in the way we can read and write data to the GPU. And the way to do this is to use images, so textures. So the first thing we need to know is, okay, how is my data structured? I know it's an array 3 here, right? So it's an array 3, so I need to assume that the data comes from RGB, which it stands for, red, green, and blue. But in our case, red is going to be X, green is going to be Y, and blue is going to be Z. Now, I need to also find the right size, because I need to specify how much I want, how big I want the texture to be. But it has to match our cubes, otherwise I would overdraw. I would basically put too many points or not enough points, right? So here I know that I can put the square, and it will basically find the correct size, basically rounded up to the square value. So if I just put RGB, I know that my data is XYZ, and square, make a square texture that fits the number of points that comes in, right? And now, very important, I also need to actually, if I put the fill up, you see that I'm gonna put more value, but technically if I have less value, then it's fine that I have to have a missing value, because if it's a square texture, maybe if I have more more boxes that I can fit, because my array is not big enough in a way. I'm gonna remove the animation of this texture so it's a bit easier on the eyes. Now, what I need here, how am I storing this data? I know from here, if I visualize my data, okay, I have negative values, and I'm happy because they are actually all integers, even though they are negative. But in the texture, you need to specify, is it gonna be a U byte? So is it gonna be only a positive value from 0 to 255? Is it gonna be 16 bits and as a floating point? So a value that can be negative and positive. I need to basically specify the format. And I think this could work as well. I would say RGB in 11 bits, because the data doesn't really go too high in terms of range. But this is something you have to deal with. It's not that easy anymore, because we need to encode this in the texture, and the GPU understands all of these different formats. But it's just for us a way to say, I'm going to take these values and put them into numbers. And if I don't have the right precision, so the format of the pixel is wrong, then I'm going to lose information. Everything is going to be, if I say, for instance, it's going to be 8-bit U bytes, then the negative value should be wrong. They should be interpreted as 0, actually. But we'll see that. We're going to play with the pixel format and see what it looks like when we start to actually visualize the position. So let's for now take the easiest, RGB 32-bit. It's a bit overkill because you have too much precision, but I think it's fine for the example. We'll play with this a bit later. We have encoded now our data into an image. Now, what can we do with this? We can do many things. The first thing would be to simply try to visualize, but to do this, I need to remove this mesh instancer, which uses the arrays as data and use the other one called mesh instancer from texture, which is I would say the most optimal one. So I'm disconnecting here, right? Connecting my cube again, I mean the trigger, the shape, this doesn't change. And now you notice that instead of having arrays everywhere, I have textures. A texture for a position, rotation, scale, the color texture, exactly the same thing. You have 5 textures here, 5 textures there. And then other extra information, so you can multiply and basically make some operation of the texture quite easily. So let's try directly. I'm taking my position and I'm pasting it here. And you see, that's exactly the same result as if we were using the mesh instancer with arrays. So it means that this conversion was okay. Now let's see what happens if I change the side. So don't pay attention to the visualization because it can be a bit misleading, the vis texture. Just see the result here. If I'm changing the way I'm encoding the data into my image, notice that we basically lose some precision because, as I said, all the name, it cannot have negative value. It's a U byte means unsigned byte. So it's going to be 8 bits and you cannot have negative value. So I'm losing, of course, all the values on my cube that are, if the center of my cube is 0, 0, this is the upper right corner. Everything is positive. Here it's negative in the Y value. Here it's negative in the X value. And there's also negative in the Z value. So if I put RGB, this doesn't really work. But if I could put RGBA with 32 bits, it seems to be okay to have negative values. So everything is correct here. So I hope this was, I know it's a bit difficult to understand at the beginning, but it's really the key to developing your workflow with cables and do more effects. So quickly, let's try to make another, maybe to animate the cubes now. Because I said, cool, we had the timer that was updating the array, but now that we have this texture, how do we actually, update it? Right? Because we still need to have this timer that comes from the CPU and modify something on the texture itself to be able to play with it. So I'm gonna drop this and only play now with the texture. So what if I wanted to actually scale this cube up? Because for now, I can, of course, modify the position here by saying I want more cubes, but I cannot really, I can multiply, which is fine. But if I want to multiply only on one axis, I'm already a bit stuck. So there's an op that we didn't see, I think, so far. It's called transform array 3. And there's also smart, so you need to connect to a trigger so that only transform when it needs to. And this up, what it does, it allows you to scale, rotate. So I can say I want to scale only on one axis, for instance, right? And this is happening, it's completely static, right? It's just, I'm scaling everything and then I'm transforming this to a texture. So the values here now are a bit different. Let's compare, right? It's really just a multiplication. See, you have this -2, -2, -2, and it becomes -4, -4, right? So this is really what we are transforming and passing to our texture. So it's already, okay, a way to modify and the initial position of our points. So now how do we start to animate? So a cool thing, if you want to have a natural effect, and it's the basis of all creative coding basically, is to use noise. Noise, I think we've seen this before, is a way to animate, to basically create a texture that moves in a natural way so that when you look at it, it looks aesthetic and not really jittery or completely random. So we know how to create this noise texture because if it's a texture and we need to create it, for sure we're going to use an image compose, right? We basically need a way to make this layer, this Photoshop layer. I like to use this image, but that can be animated. So this image compose needs for sure a trigger. The trigger can come from anywhere. So here, this is just a continuation of my sequence. So why not connect it here? And I need to put the right size. So I know this is the size of my position and I want to animate my cubes So the texture has to be exactly the same size so I can start to modify. So why not connect the texture here as input of the base texture? So this, and change this to a 32-bit texture so there's no warning. So that texture now is 12 by 12, matching the size of my point cube. So if I just visualize the texture here, it's going to be exactly the same, right? But now that we are in this image compose realm, we can start to modify whatever we want here, and it will actually modify the position of the cubes themselves. So let's imagine I'm doing, as I said, a noise. So a cool noise would be the Perlin noise. And we have many variations, of course, depending if you are on the GPU or not. So here, it's directly a Perlin noise. And so I'm not going to use the position of the texture. If I make a Perlin noise, I'm just using the initial input to get the right 12 by 12, but I'm overriding whatever I put here for this Perlin noise. So now if I connect the output here, well, it doesn't look very good because everything is completely upwards and positive values, and it's not really what we want. But just to show you that it works, now, of course, the position is driven by this noise here. Well, if we think about it, the noise is not really going to be to replace all the values, but more to give a sense of movement to our initial positions. So first, how do I animate my noise? In the Perlin noise, you have, you can first define like the range. So if I put this between -1 and 1, you would see it makes sense that it's on this axis. Then I can specify if I want the noise to be on one axis, one color or RGB noise, and then I will have random values. And then there's always a noise. You can always scroll in the noise like this. So it's basically any axis, doesn't really matter, will go through the noise. So if I connect now my timer to my noise directly in, I don't know, let's say the Z axis, already I have some kind of initial movement. I could replace and use that directly as the position as I'm doing here, or I could just add to the initial cubes. So I would give slight variation, but still keep this square pattern that we had before. Right, so this is what I'm trying to do now. So how I would do this, I would first create a variable here for cleanliness and say, okay, I'm going to create a variable. I'm going to call this position texture. I'm going to get that, here. Okay, so I get, for now, my noise doesn't do anything. I'm going back to the original cubes. But what I can do, though, is to modify each individual instance by this noise. And the way, before I do that, maybe just let's put a material because it looks really ugly. So first, let's try to put a new thing we didn't really cover, the PBR material. So I'm giving you hints, right, to where you could, there's a cool video on the YouTube, Cables YouTube channel already on PBR. But basically, it's a way to use physical based rendering. So you have much better lights and it looks more realistic in a way. And the way it works is you first need to specify this kind of environmental map. Sorry, I'm having trouble saying it. For instance, this one. And when you have the environment light, then you can also put the material itself. So PBR material. And now if you, let's make the cubes a bit bigger because you start to see in the cube that there is some kind of reflection. So with the PBR material, you can play with the light, and you can play, most importantly, with the metalness of roughness. So if you put more rough, it looks like plasticky things. And on the other hand, if I put more meltiness, you will see that it starts to reflect like as if it was made of aluminum or some kind of metal. And you see now in the cube, it seems that there is a spot here, a light, and when I move around, it gets reflected on the surface of our cubes. This is this environmental map that we have here that I can actually change. Let's say park, and you would see there's some kind of trees and the sky when I look up, right? So by combining, you can actually create your own, and it gives a sense of real. It's like we have the cubes that are really in the physical environment that we see every day with our own eyes, and it helps realism. So this is why all the modern game engines, they use this PBR, this kind of Uber shaders, or you have all the different options to play with roughness, metalness. We don't have like subsurface scattering, but many different options. So you can also add more textures to make it more real, like roughness, bump map. I mean, a lot of stuff that is covered in the YouTube video. But just wanted to show this example here. It's metallic, so it's like it's reflecting this environment light. Okay. Now let's continue. So I'm going back to my cube, saving. And as I said before, I would like to use this noise in a way so that we can modify and keep a sense of a cube, but still have individual variation. So the op to do this, because there's always an op for this, it's called instanced displacement map. So for now, it doesn't do anything. So it tells you, okay, I'm playing on the individual instance. I'm not moving all the cubes following one noise. I'm going to move individual instances by a texture. I'm going to connect this. And of course, you need to start to play with it because by default, it would be wrong because I'm only playing on one channel here. But what I want is to activate all the axes, play on RGB. So it's a bit of tweaking, I have to say, to make it work correctly. So the trick here is that for now, all the cubes are completely aligned. So whatever I would play here with my instance displacement, if I put more strength, I'm going to displace all the cubes exactly the same. If you want, I think this op is a bit buggy, to be honest, because this technically should work on individual instances. But I found a quick way to fix this. If you want really all the instances to move, what I would do is to simply play with the transform array and start to put random rotation to each individual instance. I mean, to all the instances, but then they're going to be displaced once again by this. So let's say I'm putting 12, and then I'm putting 345, and then 87. And now, because I've started to rotate each instance, when I play with this displacement, I mean, it's a bit too strong, but if I go back to strength, I still have this sense of cube, like in a frame, and at the same time I have the individual Perlin noise that I can play with. So without this, it doesn't really work, but I think this is a bug of the op. It should not work like this. I've activated the channel RGB. I want to play on all the different axes, and of course I can play with the scale. So if I put 10, 100, this is also weird. I don't really understand why this happens. I would go here, if I really want to play with how the noise works, I would go to the Perlin noise itself and play. If I put 1, of course the noise is going to be more structured. If I put 1,000, well, it's the same because there are just so many little instances. I can multiply, so I make the displacement bigger. I can also play with the harmonics. And the higher I go, the more noisy it becomes. So this is not very good to look at. But let's say I'm here, and then I can, of course, crank up the number of instances. I can put 20 on each axis, scroll down, and now you have this kind of that's what I wanted to have as a look, right? This kind of, it's still in a cube, but all individual instances have this kind of a life in a way. So let's go back to a material. Dial down maybe the metalness for now, like this. So yeah, this is the tricky part with the texture, is that it's not that easy to actually debug and know what is happening in the ops themselves. Some of them are, I think, a bit buggy, but it's very efficient here because look, there is no the data was created here. Now everything here, this noise and this displacement is completely managed by the GPU, so it will scale really well. If I put more cubes, I would just need one data transfer from the CPU to the GPU, and then this I can scale infinitely. I can play with these values in real time, map them to wherever I want, and it will really not. It doesn't need to pass the buffer from the CPU to the GPU. So yeah, that's the look I was going for. Now something is missing, right? It's like all the cubes are the exact same color, so it's cool. We see the env map in as a reflection, but it would still be nice to individually color everything, right? So how do we do this? In previous videos, we talked about how to map different libraries, and I've explained if you have already a library packaged as a IIFE, or if you need imports. But sometimes you just have a library that is on Node.js and there is no wrapping made for you. So it's not actually that easy to use it on your cables. So this is another parenthesis. So I will show you how to actually wrap this. And I made the code available here, so you don't need, if it's too difficult for you, the coding part, don't worry. First, I will share the op, and the op is already, the library is already packaged here, so you can just include it as we know, as I showed you before. But for the brave people here, let's try to see how you would do this simply. So the library I want to wrap, it's called I want you, which is nice, clever play on the word. And it's really good. It was made by the Media Lab in Paris, and it basically allows you to select in a nice color space that is that matches a bit more with our eyes than the horrible RGB, which is good for the computers but not for our eyes. So it's HCL for chroma, so hue, chroma, lightness, and the chroma is like, it's in a way like saturation, right? But it's a bit more subtle than that. When you can also check it out on Wikipedia or anywhere. But the important part is that you see filter part of the spectrum, and they also have some kind of presets, or they just, as you can see, select ranges of the color space. And then once you have the specific range, you click here and you make a palette. So basically it runs some clustering algorithm to group colors and then find the average color in this group and give you like this a palette of colors that you can play with, and it will be good to the eyes. So I really like this library and I've used it a lot. Of course, a way is just to simply play with this, take the colors and make a texture. So we're going to start with this, and then we're going to see how we can actually wrap the library, right? So the first thing we need to know, and I'm not going to detail this up because in Cables it's not that easy to actually take RGB values, I mean a hex JSON, something that you use for HTML, and to transform it into a texture. Fortunately, I have an op that does this for you. I can show it to you. It's called color strings to array here. So this op, what it does, it's not that big, it's just showing you the code here. It takes either an array of strings or directly a JSON, like a big string that is converted to an array, and will transform this into a color array, but in suitable format for cables. It can be an array3 and an array4 if I check this box here, and the texture I can play with, which is good because I need the mesh instancer from texture, and now this is how I'm gonna color my instances. So let's say I like this, not this one, maybe, yeah, I like this color palette. So here I say I want 5 colors, so it's already a bit limiting because, okay, 5 colors. I'm gonna take this, copy, go there, make an array. So I can do string to array. I could paste directly JSON, but let's say a string to array. I'm going there, I'm pasting this, and I need to, it's actually not very good because it's not JSON. So I will probably do parse JSON instead, parse object. Paste this and verify that it's okay, it seems okay. And now I have to remember, do this object to array, because this is actually a JavaScript array. Connect it here and say, okay, by default it's an array. It expects an array of hexadecimal strings that you use for colors. And in the end, it should give us some kind of a conversion in a suitable format for cables. So a flat array 3 or array 4, depending on whether you want to add here the alpha value, right? And also, of course, important part, this texture, so this texture that we have here, and this should actually work, which is weird that it doesn't, but let's see. Sometimes it's just a bug of the texture is there, but it's just not being displayed. So let's see. Show texture. Yes, I need to activate this, and I can multiply the width here by, this is my own op, so it's my fault if you think it's not very convenient, but it's just the way I've coded it. But basically, because creating a texture here in the viewport is also a bit costly. So I have this optimization that if I don't check it, if I just need to have the array, I don't need to basically grab a canvas and create this kind of output. So I activated it by just checking show texture. And then I'm just multiplying purely for view purposes, like the size of this texture. So here, as you've seen, I'm just copy and pasted the colors. And now I'm using this texture to color. And basically each instance is going to randomly pick from this texture. And it doesn't really matter to me because I'm not looking for a specific part of and they can be basically colored randomly, but you see that they will in a way match the same structure. It's just a bit dark. So maybe we can boost this, which is not what I wanted. The exposure, yes. So let's put this back and boost the exposure of the material. And you can play with this and see how it changes. But so now it's a bit more luminous, so it's better. So already I have this kind of better way. I mean, you can hate the colors, but they seem smooth to the eye, right? If you check, nothing is more. It's lighter. Everything is in the same range. I mean, the range that we specify by here, right? So it's in between this range, and here you can sort the colors. By the way, for instance, like this, you can specify I only want exactly this range. Reroll the palette and filter. But it would be better if we could, instead of copy and pasting everything, just include this library, which is a JavaScript library, to our Cables patch, so that we have the option of creating as many color palettes as we want on the fly. So this is exactly what I did. I have an op made for you, but I want to just quickly explain how I wrap the library from here. So what I did, I was going here, went on the GitHub, found this library, and you see it's quite old, huh? And say, okay, where do I go from here? I need to, this is what I want, right? I want to be able to just call this simple API, but you see this is old JavaScript style, and this is a node base, so required doesn't work in the browser. You need to convert this into a library that we can use in the browser. So how do I did this? Well, I cloned this code here on my computer, and basically opened the part that we wanted, the JavaScript part, and repackaged it in a way. So let me share with you my code, and so you can see how it looks like. All right. So what I did here was to simply, as I said, get the code. I didn't write any of this. This was there before. And you see that you have the requires that I said works for Node.js, but doesn't work for the browser as is. So what I added was this package, which is called a bundler called rollup. And you can also find more information about this. But simply, when you have this Node.js package, the entry point is most likely main or index.js. And you have this package.json, which specifies how the package is bundled, right? So main, I'm going to tell you this is the main file. I'm putting the name, I'm putting a description, I'm putting some, where you can find the repository, some keywords, the contributors, blah, blah, blah. What matters for us is that we add this rollup bundler so that we can transform this Node.js code into something we can use for the browser. So the first thing that I did was to actually add these these things to my dev dependency by using this npm. You can always, add, and then you can add the library you want. And in my case, I use this roll up, roll up. But I mean, it's already there, right? So you can do this on a fresh copy of the package. And then I added the dev dependency because rollup to convert everything needs some kind of plugins. So it's just add rollup plugin Terser, CommonJS. I don't want to go into detail on how this works, but it's basically a way to read the code, read this required format, and then to be able to transform it into something else. You can find tons of resources on this. But so the only thing that I did was basically to add this four, right, with rollup here, packages to this one. And I added a custom command, which is just a way that I could call build or whatever you want here, just to launch this tool. So if I do npm run build, it's gonna actually run, and you can see this here, the rollup config file and package or library. How do you define what to package and how? You need this file, rollup.config.js. And this is what you can use with ChatGPT. I mean, it's pretty simple, but you can copy paste. It's mostly in all these libraries, it's always the same. You use these plugins, you say, I want to use this index.js, which is the main entry point of my package. I want to store the result in this folder, this can be anything you want, the name. And I want this format that we know about, IIFE, sorry. And I want this to be under the name I want hue, like this. It could be any name you want. So that when I'm going to import the library, I can do window.iWantHue, and I would get basically the whole package. And I need these plugins to transform the code, roughly. So that's all that I did, basically. I added this file, and then you can add this in 95% of all the node-only packages. And with these plugins, it will basically try to do its best to convert and use browser-compatible APIs. I run this, and I get this library, which is, as you see, it's defined as a function that is invoked after, and everything is going to be wrapped under this name that we specify. And it's minified, so it's also optimized in one big string. So that's how and once again, the package is already there for you online, so you don't need to do it yourself, right? And just to explain how I did this, and basically you can go on my own version, which is just a fork, and you have the library already here. So now when we go here, back to our project, we have this new op that I called generate palette. And now let's see the options here. Basically, it's a bit the same of what we saw before, right? The hue, max, the chroma, the lightness, the thing we saw on the left, and some kind of preset. And you see I've copy and pasted all their predefined preset as well. And how many, this is keep this as a default value. And just at the beginning, how many colors you want, right? So now let's say I want 12 colors. And for now, I'm going, everything is possible, like the whole range is possible. And it will generate these hex values. It's how the library works. So this fits nicely with our color strings to array. This is why I introduced it before. So if I just compose these ops, now I start to create any palette that I want very easily. So I can save this, and I can show you the code. It's basically a wrapper around this. I'm just clamping some values, checking if I have the library, multiplying to get the right color space for cables, for the library, running the simple command line that we saw from the node package, which is just run this, get back the X strings from there, and set the output. So this is all it does. Now, if I go and I don't play with the preset and I want to modify the value, I go to custom, and now I can specify the range of my possible values, right? And you see each time you move the slider, it reacts in real time. So that's all there is. And now we have cool looking colors that are good looking, and it can be changed as we want on the fly. So I hope this lesson was not too scary. I've seen some, showed some different things that are a bit more advanced, and of course I would go over this in more details, going back to the instance displacement, the noises, everything in future lessons. But I think it already gives you an idea of what's feasible. Something we never touched on was also all the HTML part, and I didn't forget about it. I just in Cables has a lot of ops to actually interact with the HTML part of the web. So the most common part is the div element, and you see this is not a texture made in WebGL. It's something that is actually pasted on top of your scene, right? So you can write anything you want, but you can actually create real HTML, not just text here. So if you know HTML, you can put login forms, you can put buttons, anything you could do by just coding. It's just you would write it as a text here, but instead of just putting this in one line, we have this string editor that we saw before, and I can put myself in HTML and simply connect the string here, right? And now I can put something like a paragraph or span, my cool title, write HTML here and use that as I want. I can also style it. You can put inline style, which I would actually not recommend doing, but you can have an external CSS file. So let's imagine that I want to just have a title, right? I'm gonna name this element ID, I'm gonna put title, and I'm gonna just remove the span because by default the div element actually creates or wraps everything into a div. So it doesn't change yet. Now I'm gonna create an external CSS file. It's exactly as if you were coding. Putting this so that it stays on top, and remove the style from there by default. So this is how it actually goes on top of the canvas. But when you position absolute and the Z index quite high, but now I've been replaced by an external style sheet, and you see I have my cool title here. Now it would be cool to actually change the font because this is ridiculous. It doesn't match the coolness of our cube, I would say. So there is also a way to load the font, right? This is actually what I pasted here. And I'm basically loading a font called Membra, but we don't have it here, so it's still using the default font. Fortunately, Cables has something called font file, or you can load any font you want. You can just drag and drop a font from your computer. But what I did is I simply cheated. I opened the example. I took the path to this font because it's hosted by Cables, basically. Close this, paste it here, and now saving, reloading, and technically, if something worked and I put here the right family, yes, now my font is loaded and I can use it. So maybe my cool title is not good. Maybe we can call this, spinning cubes. Yeah, and the camera is actually too close at the beginning. So maybe we could also, put a transform view somewhere or reset the position. So I would say, let's put here a transform view and play a bit with the position at the beginning, right? And then go here. Yeah, it's a bit too close maybe. I mean, it depends what you're looking for at the beginning, right? Because if you put it too far, then of course you're not going to be able to zoom closer than this, but maybe it's enough at the beginning. What we could do is also play with the transform view itself. Remember that we have this timer and the sine wave. So maybe we could also use that as a way to rotate our camera so that, it looks like the cube is always rotating in a way. So if I use my sine and I use this on rotate Y, and maybe I need to punch the values because they're, of course, they're going to be a bit small. But if I boost the amplitude to 180, see, now I have some kind of spinning cube, and I can reduce the frequency to make it slower. So it's just a way to have the multiplication here. So now the cube is moving automatically. I can zoom in and out. Now, of course, if I start to move the camera, I'm not going to be centered. So I have to be careful with the position Z, right? I can just tweak the camera itself, but I like to have this centered. So when I turn, my cube is always in the center like this. So you see, I'm adding small details that we've talked about, but it starts to create this kind of a more complete experience and very optimized, as I said before. Cool colors, interesting movement, typo, and basically the sky is the limit now. Imagine just giving you some ideas. You could connect this to some kind of database so that many people could save their parameters. You could load them if they have to log in. You could connect to data that you have hosted on your servers so that each cube now maps to a real point, and something happens when I go over a point, something like this. So there are a lot of different techniques we will cover in future tutorials, and I hope that this one gave you some perspective about what's possible. Remember that we talked about importing 3D assets, playing with the images, sound, and so before closing up this, wrapping up this video, I want to warn you that I'm going to continue this tutorial and add a bit of generative sound. So if you like this tutorial, please let us know, right? Try to connect on social media, on the website, wherever, and give us some feedback about the whole series. Otherwise, I'll see you in the next one.